The arms, legs and torso are now rigged, although we do still need to add in the roll and twist joint functionality, plus some squash and stretch. Before we do that though, I wanted to explore some space swapping options. Now I know we have skimmed over this in previous videos, but I wanted to dig a little deeper into them and explore how we add them in for multiple parents. In this video I will focus on the elbow pole vector controls and also the IK hand controls, but these options can be applied to anything really. Let's look at the elbow control first. What we want to give the animator is the option for this control to stay in world space. So basically as it is now. Or we want the option to also make it follow the arm IK control. You will notice that I've added a follow attribute, which we will be using to switch between the two states. Okay, let's open the node editor. Let's bring in both controls, so the elbow and arm controls. Let's hide the shape nodes too. We don't need them at this point. Just move these over. Because we want to move between the two states, we need a way to swap or blend between them. And if you remember, we can do this with a blend matrix node, something that we've used a few times already. Press Tab and create one. And let's rename it to arm PV left space blend. These names seem to get longer and longer. I may have to revisit some of these. Let's hop over to the attribute editor. And open these. So up here, under the Input Matrix tab, we define the world space position of the elbow control. So we essentially record where it is now. Down here, we can use the Add New Item button to create new targets for it. Again, we've touched upon this before. First, we need to store the elbow control's position. So we need these values here. Let's copy this tab so we can reference it. Okay, so we need the blend node over here. And all we need to do is copy the values across. So from here to here. Okay, that's stored and it will act as the world space position. Now you're probably wondering why I didn't just connect the nodes and then disconnect them again. Now basically if you do this, the values will appear, and as soon as you disconnect them, the values will disappear. So this is why we have to manually copy them across. Let's add another item now. Here we go. So we can now connect the arm IK control to this new section. So the elbow control can move to it and follow as it moves. So take World Matrix 0 and connect it to the blend node's target 0, target 0 target matrix attribute. Wow, that is a mouthful. Now we want this to drive the elbow control. So connect the blend matrix node's output matrix to the arm PV control's offset parent matrix attribute. Okay, so we can see the control has now moved to the wrist. Let's open this back up and close this. We can now use the envelope slider to blend between the two states. So now the control is in world space, so it doesn't follow the arm control. Just bring back the node editor. If we set envelope to 1, the control moves back to the hand control. And then it follows as it moves. So this works, but it's not ideal. We would need the elbow control to stay where it is rather than move to the hand. Having it this close to the hand can cause the IK to flip. So how do we keep it away from the hand but also still make it follow the hand? Well, we need to use something that will act as an offset. So let's just create a locator. And let's rename it to arm left IK swap position, or POS for short. Add the elbow control to the selection and then go to Modify, Match Transformations, Match All Transforms and move the locator to the control. We are going to use this as a proxy for the arm IK control, so the elbow control will blend to this instead. So to make the locator follow the arm AK control, we simply parent it to it. If I move the arm control now, the locator follows but maintains that offset. What we need to do now is use the locator's position instead of the arm control. So, take its world matrix 0 attribute and connect that to the blend matrix node instead. So it goes into target matrix here. And that's set up now. All we need to do now is make the follow attribute control the blending. So take follow from the arm PV control, or the elbow control as I've been calling it, and connect that to the blend matrix node's envelope attribute. So that's going to control this. Okay, so the arm control is set to world, which means I can move the arm control and the elbow control stays where it is. If I change this to hand now, the control moves but to the locator, so it's maintaining the distance so we don't get any flipping issues with the IK. This also means it will follow as the arm moves. What makes this even better is the animator could place the locator wherever they like. They could even animate it for even more flexibility. So that's a basic two-way space swap. So let's move on now and look at something with more options. With the arm pole vector control, I'll use its correct name, but you know what I mean if I refer to it as an elbow control. We have just two options when it comes to space swapping. So how do we approach the hand, which has 4? Well, it's very similar to the elbow control, but also a bit more complicated, so I'll try my best to take it step by step. But if you're not sure, please feel free to look at the source files and pick apart the rig so you can see what's going on. So let's jump back into the node editor. So we have these options here which represent these controls: the cog, hips, and arm root control. So just as we did with the elbow, we need a locator for each of these controls so we can maintain that offset. Duplicate the arm IK space position locator and move it out of the hierarchy. Let's rename this to cog left swap pos. Now duplicate it twice and then rename these, so hips and clavicle. Select those and then select the arm IK control. Now use the match transformations tool to move the locators to the arm IK control's position. Remember that the locators can be anywhere you like, so if there is a better position, you or the animator can move them later. Okay, these are all in position. Now we need to parent the locators to the controls the hand will need to follow. So the cog locator is parented to the cog control. The hips locator is parented to the hips control. And the clavicle locator is parented to the arm root control. I'm referring to it as the clavicle because this will ultimately control the clavicle joint, something we will cover later in the course. I'll just show you these in the outliner too. There you go. So these locators will move with the controls they are parented to. There's the clavicle locator. Right, let's start wiring these up. Create a new blend matrix node. Call it arm left space blend. Select the arm IK control and open the attribute editor. So we need to store these values in the blend matrix node, just as we did with the elbow control. Let's copy the tab, select the blend matrix node, and copy the values across to store them. Remember, this will be the world space position. Okay, now add 3 more items. One for each of the locators we created. Now connect the locators to the blend matrix node. So the cog locator world matrix 0 attribute goes into target 0 target matrix. the hips world matrix attribute connects to the target 1 target matrix, and finally the clavicle world matrix attribute connects to target 2 target matrix. Okay, those locator positions are now in the blend matrix node. So we can then use that to switch between them. Right, let's make some room. Unlike the previous blend matrix node, we can't rely on the envelope attribute to dictate where the RMIK control goes. All this will do is gradually blend between each of the locators, whereas we want a distinct snap to each. So what we need is basically a switch of sorts. Create a new node, but this time create a condition node. And let's call this arm left space condition. So what a condition node does is checks two values and compares them. Depending on the outcome, a different value is then output from the node. So the first term here is compared against the second term value. We have an operation which we can change depending on what we are checking. So by default it will see if both values are equal. But you can check if the second term is greater than the first term, less than the first term, and there are many other options you can look at. Let's leave it as equal for now. So when the first term is equal to the second term, the node will output values from the colour if true row here. If they aren't equal, it outputs the colour if false value instead. So it's quite a powerful node and one I use all the time. Let's wire this up so you can see how it can be used. Open it up first. So these are the output values and they represent each column here, R, G and B. As mentioned earlier, we won't be using the envelope slider this time. Instead, we will be using each target's weight attribute. Let's open this so we can see them. We have 3 columns coming from the condition node and 3 targets to control. So we can do this with the condition node. Connect outColor R to target 0's weight value. OutColor G connects to target 1's weight attribute. And finally, OutColor B connects to target 1's weight attribute. So we will be using the condition node to switch the weight values on and off, which will change what the hand control follows. Speaking of which, let's bring that in now and move it up here. So what we are interested in is the follow attribute here, which has the 4 options in it. Connect that to first term. If we look at that now, you see first term is set to 0, which represents the world option. Drop down boxes or enums like this always output numbers, so world is equal to 0. We can use this first condition node to check if the follow attribute is set to anything other than world or 0. It will then use the attributes below. Okay, so we now need some more condition nodes, one for each locator. Just close this, and let's duplicate this one 3 times. And let's rename these so they have the correct control in the name. So with these 3, we will be using them to check if the follow attribute is set to that control's number. And if it is, pass that on to the master condition node. This will then switch the correct weight value on and off. First we need our follow attribute again. So connect that to each of the condition node's first term attributes. With the cog condition node, we want to check if the first term changes, and if it does, has it changed to the cog option. If I change the follow attribute now to cog, and look back at the condition node, you will see the first term is now 1. So we need to set second term to 1 as well. So when these are equal, it will tell the main condition node we want to follow the cog control, and then that will activate the cog section's weight. Let's look at the hip condition node and change follow to hips. First term is now set to 2, So we need to set second term to match this so it triggers when the animator wants the hand to follow the hips. Okay, let's change follow to clavicle now. So first term is now 3. So add that into the clavicle condition node's second term box. Because this is a simple setup, we only need to worry about the first R column here. So we just need outColor R from each condition node. Let's open these first. So we need the color if true options here. From the cog condition node, connect outColor R to color if true R on the arm space condition node. Next, connect the hips condition node's outColor R attribute to color if true G, and then the clavicle condition node's outColor R attribute to color if true B. So when one of these condition nodes matches the follow option, it will tell the main condition node, and that will then update the blend matrix node's weight values. You can see the boxes here are now yellow, which means they are connected to something. What we need to do now is change all the color if false attributes to 0. So if the follow option isn't one of these, it will simply set the weight attributes to 0. With this first node, we also want to change the operation to greater than. So we are saying if follow is set to an option that is greater than world, then return a true value below. If I set follow back to world, first term is now 0, so the condition node will be outputting the false attributes below. This will set all the weight values to 0, meaning the hand control stays in world space and doesn't follow any of the locators. Let's set it to cog now and check it. Okay, this doesn't look right. We should only be getting one value below set to 1. Let me check the other condition nodes. Right. The true value should be 1 and false should be 0. So let's just update those. That's better. Just the 1 now. So because the first term is now greater than the second term, this is the value that will be sent to the weight attribute. And each of these will change depending on what the follow attribute is set to. So you see, the first is now set to 1, and the others are set to 0, so are deactivated. Let's change to hips now. And the first term is now set to 2, and below the 1 has moved to the second column, or the G column. So let's test this on the control. Okay. It would help if we actually connected the blend matrix node to the arm IK control. Okay, move this over. And connect output matrix to the arm IK control's offset parent matrix attribute. Well, it's moved, so that's a good sign. Let's close this. So the arm should now follow the cog control. It does, great. Let's swap to hips now. And it follows the hip control. Let's move the root control now, which, as mentioned, will eventually control the clavicle too. And switch follow to clavicle. The hand now follows this control. And world just leaves it floating in world space. So we do have all these locators now, but as mentioned earlier, the animator can use these to control the hand's placement. So it could be sat on the creature's hips, for example, as the hips are moving. Okay, let's reset some of these. Time to do some cleaning. We want the locator's attributes to be set to 0, making them easier to use and animate, and also get back to the default pose. Again, we can simply move the values down to the Transform Offset Parent Matrix section. And that can now be moved and animated, and easily reset to 0 to get back to the default position. Let's do the same on the other locators now. And clean those. Okay, good. So that's space swapping set up on an object with 2 targets and also one with multiple targets. And as mentioned at the beginning of the video, this can be applied to anything really. If you wanted, you could go back and rework the head, removing the constraints we added and swapping them for this more economical solution. What I would also suggest is maybe adding a new attribute here, one which will control if the locators are visible or not. This will just declutter the scene when the animator doesn't need them. Simply connect the new attribute to the visibility attributes here. Okay, so now I need to go through all that again and update the right arm. And I can also do the same process with the legs. So I will do that and I will be back in a few seconds. Yep, I'm a fast worker. Okay, here we go. All the space swapping set up, and feel free to pick this file apart if you're at all unsure with any part of the process. As you can see, I also added the attribute I mentioned too, so we can hide those locators. So that's space swapping covered. I think next we will go back to the limbs and investigate adding the roll and twist joint systems.